So, today I want to talk to you about biomes and largely how we do terrain inside of computer graphics. So, terrain is like these are a couple of rocks, even a large rock here that you might put into something like a game or a movie, but our terrain is significantly larger by scale. Think about just the size of a mountain versus the size of a big rock in your front yard or the size of a house. Like the scale of terrain we're thinking about is so large that us as a viewer shouldn't be able to see the end of it. The terrain sort of encapsulates terra firma, the world underneath us. And as such, terrain itself can be described in a lot of ways. Maybe you've seen a map like this before. This is a topographical relief data map. And what goes into this is showing us using different colors where different things are and where different height levels are, including where like snowy peaks might be, these little trails indicating where rivers and tributaries are. And as we get closer and closer into where there would be like grass growing, they turn it to green, whereas this would be stone and maybe this would be different grade. But we can see from looking at this based on the shadows and everything else that there's sort of a slope to everything happening here. And so it's fortunate for us when we're thinking about this kind of thing, especially the way we do it, is we don't think about anything with an overlap. We think about terrain kind of like this, like a flat plane that gets raised up in some spots. So let's talk about some of the things that can happen so that you can start to recognize different types of terrain and what creates their origin and what creates their look. So one of the most common things you think about when you think about a mountain, they call this an uplift. So on the left is a pretty standard type of glacial carved out rock. And this is a case where glaciers would have pushed through and been shoved as the ice expanded and carved out these edges and rocks. You can see the shape of them themselves. It looks really pushed and really carved through. There's other forms of uplift as well. For instance, a volcano is where magma will pool up from the earth and it will start piling up on top of itself, and it creates this sort of conical shape to it, which is why volcanoes are usually pretty round and pretty, sometimes they're domed and sometimes they're conical sweeping up. We also have block mountains, which is where two fault lines hit each other, and instead of impacting or tearing apart like in an earthquake, they sort of tear apart. In this case, they shift and one goes over the top of the other. This is how mountain ranges are created. So if you've ever seen a large ridge, this is generally a block mountain. And then we have things like a fold mountain. It's pretty similar, but instead of them coming up, one of those folds up and under itself. And again, it's another type of mountain and rock formation. When you're trying to recreate a specific scene or a specific part of the world, or even something from a fantasy sort of setting, you always want to think, what was the geography of here? Thinking as far back as you can. It's like, what was the millions of years history of the shape of this thing? Now, there's other ways, though, that things can get eroded away, whereas uplift is how things get pushed up so that it's not all flat. Erosion comes in a lot of forms. One of the most common of these forms of erosion is water. So here is some great example in the Serengeti of water erosion, like it's been through a raining season. And this roughly loose soil was turned into these very thin rivulets and tributaries. We also have erosion like on this fjord over here, where you can see that there is this gradual pulling of the water comes in and it starts pulling sediment out towards itself. Or here, this is over in Scotland, I believe. And over time, even this tiny little stream keeps pulling more sediment. And as it pulls more sediment, sort of like dirt, sand, and rocks, down the little river, more of it needs to make room. Think about like if you've ever been in a sandbox and you scoop it away. Well, it doesn't just leave there. The other sand starts piling in. And so over time, this little tiny creek can end up creating a large channel or ravine. That's why you tend to find water in like downward areas like this, because they tend to pull things down with them. Now, erosion can also come in different forms. As I mentioned, glacial erosion is how a lot of like really large mountain ranges get carved. This is where you tend to see like big, heavy cliff faces tend to be some sort of glacial erosion. We also have things like wind erosion. So there's like sand caves and things like that. In some regions of the world, the wind is blowing sand, which is just like tiny, very sharp rocks at such intensity over such a long period of time that it can gradually erode into these very interesting, winding and smooth shapes. But also erosion tends to be sedimentary erosion, or this erosion of just something is heavy wants to pull itself down. So if you think about this, like an uplift pushes up, and then over time, everything wants to settle down and get back into a state of equilibrium. So that's why we tend to find like these rocks are falling off the sides of this mesa cliff and gradually piling down into smaller and smaller rocks. And these things all tend to sift into each other. Eventually, given enough time, they would flatten out, all things being equal. No other uplifts and no other events. But that would be a really long period of time. For us, we're just in this tiny sliver of the lifespan of something. And so we're going to see it this way. And we're seeing everything in the progress of being pulled down and gravity kind of winning. Now, when we do terrain in computer graphics, we think about this as our process. So our stages are very similar, where we'll often use texture generators to lift up terrain and then pull in procedural generated things to pull things back down. There's a lot of great tools for this, World Machine and Gaia, to name a few, and even programs like Unreal Engine and Unity have built-in terrain systems. And they'll work on the same principle. We potentially take a flat plane and we push everything on top of it. Water as well can be just a big flat plane that sits on top of everything else. Is how you usually do like water in a scene like that. It's just a plane that can cut through everything, because why wouldn't it be? We don't need it to be anything individual. Now, if you take a look at any traditional game or movie and you rotate it around a little bit, just like our buildings from the last exercise, there's nothing in the back because there doesn't need to be. This is a boundary break screenshot of the Legend of Zelda Ocarina of Time, one of my favorite video games of all time. And when you're in the world, it feels very full and very complete. But when we start taking a step back, you realize how incomplete it really is. And one of the most common techniques is to, out of the player's view, set like things like mountains high up and in the distance. And often these are really simple models because they're so far away, but it gives us a sense that there's something over there, even if we're never going to get there. Because this is the limit of like how far the player can go in here, but we need to be able to see all those things around it. So the terrain is the stuff we're on, and outside of it is everything we build on top of it. So that kind of leads to an interesting question, is like, well, when should I use a terrain and when should I use a model? And this is when people first get introduced to terrains and they say, well, I want to make a cave or I want to make a big arch. And terrain doesn't really do that very well. It's very good at being flat and straight. Things like overhangs and mine shafts and caves and things like that are much better handled using regular geometry. So when do you use terrain and when do you use like a traditional model? Well, for terrain, think about it as the structure underneath everything. So I've got all these rocks piled up, but under it, I can see that there's a slope of pretty even rough sediment. So this sloping from here down to here would be great for terrain. However, these rocks we would want as physical geometry. As we can see, this has got a big, heavy overhang. And as I'm going to explain next video on displacement, we can't really get these kind of overhangs when we're using this technique. So anything that's like big, main pathways, smooth or sloping surfaces, we tend to like to do terrain on. But anything that needs lots of little details, it needs sharp edges, or it has repeatable features, or we want to draw someone's attention to it. I want a big tower or a specific rock face. These are things that are really much better left to geometry. So if I was breaking this down myself, I would be looking at these pink areas might all be terrain. And then these would be like kits of rocks and all the other colors that would just sit on top of everything else to give me my overall final effect. In fact, if you're looking for something like this, you should check out YouTube videos of people speed level designing in something like Unity or Unreal Engine 4, and you'll see they take just big, flat, really slopey terrain and just start slapping stuff on top of it. It's kind of cool, actually. So that's it to talk about this one. Next time we'll talk about foliage.